So hello everyone, welcome to this video. So in my previous video I had solved some problems related to inverse Laplace transform of partial fractions, right? So that is done. Now we are left with only two of the very important concepts. One is applications to solve ODEs and another one is, which I am taking right now, convolution theorem. Okay, some problems based on convolution theorem we are going to solve. So this involves pure integration. Okay, you should be knowing some of the important kind of integrations here in order to solve. Okay, so let us see what is this convolution theorem. If L inverse of f of s is equal to f of t and L inverse of g of s is equal to g of t, then L inverse of f of s into g of s is given by, that is convolution with these two terms. L inverse of f of s into g of s is given by integration from 0 to t f of u into g of t minus u du. Okay, or we can even write it as integration from 0 to t f of t minus u into g of u du. Okay, either way you could be writing it. So this is the formula for convolution theorem if you consider, that is L inverse of f of s into g of s. Okay, yeah. Hope it is clear how to solve these kind of problems. This is the formula. Now let us discuss with some of the problems. So let us see with the problems now. So this is the first question related to this convolution theorem. Find inverse Laplace transform L inverse of s square divided by s square plus a square into s square plus b square by using convolution theorem. Okay, so let us see how we could be solving this problem here. First, this is the f of s term given. So here we could be writing f of s as, first I'll write it again, s square plus a square into s square plus b square. So we could be writing this further as s square. Now what I am doing is I am splitting it into s divided by s square plus a square, s square plus b square. Okay, so now this could be written separately as s divided by s square plus a square into s divided by s square plus b square, right? So if you compare here, this is f of s and this is g of s. Okay, so L inverse of f of s into g of s, you should be doing it separately. Okay, so hope it is clear. That is L inverse of f of s into g of s could be written as L inverse of s divided by s square plus a square into s divided by s square plus b square. Okay, so that is given as, according to the formula, L inverse of f of s into g of s is equal to integration from 0 to t f of u g of t minus u du, right? So let us solve it now and let us see what we are going to get. Okay, so here we have in terms of f of u, right? But we have written the values of f of s and g of s. Okay, we should be getting the values of f of u and g of t minus u to further proceed in these kind of problems. So how to get it? Let us see. So here, according to our substitution, f of s is equal to s divided by s square plus a square, right? And g of s is equal to s divided by s square plus b square. Okay, so now what is f of t? F of t is generally given as L inverse of f of s, right? So do that. F of t is equal to L inverse of this part, that is s divided by s square plus a square. Okay, so this is actually cos at, right? L inverse of s square plus a, s divided by s square plus a square is equal to cos at. So f of t is equal to cos at. Okay, so now in order to get f of u, just replace t by u. Okay, so that is f of u, therefore f of u would be equal to cos a u. Okay, wherever t is there, put u. So this is the f of u. Similarly, try to find g of t minus u now. Okay. Now, if f of t is L inverse of f of s, then actually g of t would be also L inverse of g of s, right? So that is g of t is equal to L inverse of g of s, that is s divided by s square plus b square. Again this is cos, again this is of the form s divided by s square plus a square, but in the place of a it is b, so this could be written as cos bt. Okay, but they have asked g of t minus u, so in place of t substitute it as t minus u, that is cos b t minus u. Okay, so this is the value of g of t minus u. F of u we have got, g of t minus u we have got. Now nothing much to do, only the further integration part. Okay, that is L inverse of s square divided by s square plus a square into s square plus b square is equal to integration from 0 to t f of u into g of t minus u. F of u is cos au and g of t minus u is cos b t minus u. Okay, so this is cos b t minus u du. Okay, so now we should be integrating. Before that, this is of the form, if you observe carefully, cos a cos b, right, where we are having the value of a as au and b as b into t minus u, right? So we are going to apply that identity now, cos a cos b. So we know that cos a cos b is given by 1 by 2 cos a plus b plus cos a minus b. Okay, so that only we are going to apply here in this integration before doing the integration part, that is one by 2 0 to t cos of a plus b, that is a is au and b is b into t minus u. Okay, plus cos of a minus b, that is au minus b into t minus u du. Okay, now do the further simplification. 1 by 2 0 to t cos au, so just multiply, so au plus bt minus bu, and here we are having plus cos au minus bt minus minus plus bu, okay, into du. So now what I am doing, 1 by 2 0 to t cos of, so here in au minus bu, u is common, right? So that I am taking it outside, and a minus b, and I am taking it constant u outside. Okay, plus bt plus cos of, here also the same thing, u is common between au plus bu, so a plus b remains into u minus bt du. Okay, so now 1 by 2 now do the integration part, that is integrate this whole term with respect to u. Okay, that is integration of cos is what, sine, so we would be getting integration of cos is sine, and this term as it is a minus b into u plus bt divided by the coefficient of u, not t. Okay, because we are integrating with respect to u only, so whatever is the coefficient of u, right, that you should be writing in the denominator, plus here also the same thing, integration of cos is sine a plus b into u minus bt the whole divided by a plus b, and the limits are from 0 to t. Okay, so now 1 by 2 apply the limits now, upper limit and lower limit, that is sine of a minus b into t plus bt divided by a minus b plus sine of a plus b into t minus bt divided by a plus b. Okay, so this is the upper limit part. Similarly, minus lower limit, that is sine of a minus b into, in place of u, 0 plus bt divided by a minus b plus sine of a plus b into 0 minus bt divided by a plus b. Okay, so this is done. Now further simplify and see what answer you will be getting, that is 1 by 2 sine of, so a minus b into t, that is at minus bt, at minus bt, and here we have already plus bt divided by a minus b plus here sine of at plus bt minus bt divided by a plus b minus this part here, 0 into a minus b is 0, 0 into a plus b is 0, so we are left with sine of bt divided by a minus b plus sine of minus bt divided by a plus b, right? So we know that sine of minus theta is equal to minus sine theta, right, according to one trigonometric identity. So this would be minus sine bt. Okay, so I'll change it here only, minus sine bt. Okay, so here minus bt plus bt goes, here also plus bt minus bt goes. Okay, so now what we are left with, 1 by 2 into sine at divided by a minus b plus sine at divided by a plus b minus of sine bt divided by a minus b minus sine bt divided by a plus b. Okay, 1 by 2 into sine at by a minus b, and here you have a minus sign, you multiply, so minus sine bt divided by a minus b. Okay, you group this together, plus sine at by a plus b minus minus plus sine bt by a plus b. Okay, so here in both these terms denominators are common, so you will be getting our final answer as 1 by 2 into sine at minus sine bt divided by a minus b plus sine at plus sine bt divided by a plus b. Okay, so this is our required answer. Okay, like this you should be simplifying this integration part. So in this way the convolution is done. So this is one simple problem. So we have one more problem, let us solve it. So this is the next question. L inverse of s divided by s square plus a square, the whole square. Okay, this we should be solving using convolution now. Before that, we should be splitting the whatever is there in bracket, right? So here f of s is equal to s divided by s square plus a square the whole square. So this how we can be splitting as, you could be splitting this and be writing it as s divided by s square plus a square into 1 divided by s square plus a square, where this is f of s and this is g of s, right? So here just have introduced the term 1 here, because if you multiply the denominator you would be getting this term only, so that's why I have introduced 1 there. Okay, so this would be our new value. So now L inverse of s divided by s square plus a square the whole square is equal to L inverse of s divided by s square plus a square into 1 divided by s square plus a square. Okay, here f of s is equal to, and according to the formula what it is, integration from 0 to t f of u g of t minus u du, right? So that we are going to substitute now. First you should be finding f of u and g of t minus u. So what is f of s here? S divided by s square plus a square, and g of s is 1 divided by s square plus a square. Okay, so here again we know that, right, f of t is equal to L inverse of f of s. So f of t would be equal to L inverse of s divided by s square plus a square, and we know that this is equal to cos at, right? So f of t would be equal to cos at. So similarly, what would be f of u? In place of t you substitute as u, so cos a u. Okay, so similarly g of t, that is L inverse of g of s, g of t is equal to L inverse of 1 divided by s square plus a square. Okay, and if you check the identity here, what is 1 divided L inverse of 1 divided by s square plus a square? We have discussed it in the first video, that is it is equal to sin at divided by a, right? So here L inverse of 1 by s square plus a square is sin at by a. Okay, so that would be our g of t, that is sin at by a. So what would be our g of t minus u? Sin of a into t minus u divided by a. Okay, so this is our g of t minus u. So now what would be our integration be looking like? L inverse of s divided by s square plus a square the whole square is equal to integration from 0 to t f of u, that is cos a u, and g of t minus u is sin a of t minus u du. Okay, so here divided by a, right? So now what I am doing is I am taking 1 by a common outside. Okay, so 0 to t cos a u sin a of t minus u d. Okay, so again this is of the form cos a sin b, that is cos a sin b, and here for this also one trigonometric identity we have one formula, that is 1 by 2 into sin of a plus b minus sin of a minus b. Okay, so these trigonometric formulas and all you should be doing very well, because we would be using it in most of the times in our while solving our engineering mathematics for each and every lessons. Okay, so these trigonometric identities are a base for everything which we study in mathematics. Okay, in our further engineering, here in second sem, also in third sem also, whenever we are having maths, these complicated problems requires the trigonometric identity knowledge. Okay, so you should be having a thorough idea about trigonometry. So using this formula, you are going to solve this now. Okay, so here we have 1 by 2. Already we have a outside. So next, while doing the integration, I am taking 1 by 2a common outside. That is 1 by 2a integration from 0 to t sine of a plus b, that is sine of a is au and b is a into t minus u. Okay, minus sine of a minus b, that is au minus a into t minus u du. Okay, so this would be equal to 1 by 2a 0 to t sine of au multiply, so au plus at minus au minus sine of au minus at minus minus plus au du. So au would be getting cancelled here. So you would be left with 1 by 2a integration from 0 to t sine at minus sine so this won't be getting cancelled. Here it is plus, right? So au minus at plus au. So au plus au is 2au. Okay, so sorry for that. 2au minus at du. Okay, so this won't be getting cancelled, so sorry. I thought this is cancelled, so this also might be getting cancelled, so sorry for that. So here it is plus au, right? So au plus au is 2au minus 8. Okay, so now 1 by 2a into integrate sine 80 with respect to du. Okay, so if we integrate, here we don't have any u term, so this whole term would be becoming a constant, and integration of du is u only, so u sine 80 would be remaining. Okay, and here we are having sine 2au minus 80, that is minus we are having, so integration of sine is minus cos. Okay, so that's why here we have already minus, so minus minus would be plus cos 2au minus 80 divided by coefficient of u, that is 2a. Okay, limits are from 0 to t. Now apply the limits. 1 by 2a into first upper limit, that is t sine 80 plus cos 2at minus 80 divided by 2a minus the lower limit 0 into anything is 0, so I am writing 0 plus cos 2a into 0 minus 80 divided by 2a. Okay, so this is 0, right? So we will be getting 1 by 2a into t sine 80 plus cos 280 minus 80 is 80 itself divided by 2a. So minus into plus is minus cos of we are having this as cos of minus 80. Okay, so we know that cos of minus theta is equal to cos theta itself. Okay, so this would be again cos 80 itself divided by 2a. Okay, so plus cos 80 by 2a minus cos 80 by 2a would be getting cancelled out. So we would be left with 1 by 2a into t sine 80. Okay, so our final answer is L inverse of s divided by s square plus a square the whole square is equal to t sine 80 divided by 2a. Okay, so this is our final answer. So in this way we should be solving these kind of problems. Okay, so please note this problem down, very important one. So these were the two important problems related to convolution which we have solved in this video. Okay, So in the next video we are going to solve the similar problems related to convolution only. Okay, so let us see you in the next video.